Disney Company says it plans to eliminate single-use plastic straws and stirrers in all of its locations worldwide by mid-2019. In an announcement Thursday, Disney said the step will save more than 175 million straws and 13 million stirrers used and thrown away at its theme parks, resorts, and cruise lines every year. Disney joins other companies such as Starbucks in the fight to reduce plastic waste. But as Newsy has previously reported, straws make up only a tiny portion of the plastic that ends up in Earth's oceans and coastlines. The company says it also plans to reduce the number of plastic shopping bags it uses and fully eliminate polystyrene cups.
Years or so, Mars's orbit brings it millions of miles closer to Earth than usual. This is an ideal time to send missions toward Mars, be they robots or future crews of astronauts. Generally, if Mars is closer, missions are more efficient. Probes spend less time in transit, they need less fuel, and they cost less overall. Everything from Odyssey in 2001 to InSight in 2018 took advantage of this window. Now, some lawmakers are anxious to put manned Mars missions on NASA's calendar. And a close approach could be more than just efficient. It could be the only way to get astronauts there or back safely. NASA limits its astronauts to a certain lifetime level of radiation exposure. Based on current mission designs, a round trip, just getting from A to B and back, could expose astronauts to more than those limits. That's because most of the radiation comes from cosmic rays, and scientists still haven't come up with a reliable way to shield astronauts from their effects when they leave Earth's atmosphere.
The fossil record is far from being a complete library of everything that's ever lived.
The vast majority of everything that's ever lived has completely decayed away, bones and all, even, for animals that have bones and shells. So fossilization is a very rare occurrence.
Duncan Murdoch, a research fellow at the Oxford University Museum of Natural History.
But then if you play the numbers game and think about how many organisms have lived, then fossilization is ultimately inevitable that some things will get into the fossil record.
But what parts of an organism fossilize, and in which stage of decomposition, can vary, meaning it can be hard to reconstruct a living animal from what's represented in rock. Plus, most of the fossil record is bones and teeth. To find any evidence of the soft tissue of ancient animals is incredibly rare. So to learn more about that process of decay and fossilization that can preserve soft tissue, Murdoch and his team dissect marine animals, like hagfish and lampreys, as they lie rotting in the lab. The study of how organisms become preserved is called taphonomy, and it can stink.
Yeah, it's certainly a very smelly place to work sometimes.
Smelly, but it gives them a step-by-step look at how creatures' bodies change as they decay.
The first signs that the animal is decaying is the very softest tissues like the guts and the eyes start to decay away, and then fine structures like the gills, and then things like the fins start to fall off, and you start to see the skin falling apart. And then eventually all that you're left with are some little bits of cartilage and then remnants of the muscle blocks.
They break down their work in the journal Paleontology and make the case for why rotting flesh may give a fresh look at the fossil record. Because what you don't find, and the degraded state of the material you do find, have their own stories to tell about the history of life on Earth.
Some things are hard to remember, others are hard to forget, especially things that are traumatic. But kids, it turns out, are better than adults at forgetting the bad stuff. And now scientists think they know why. According to an animal study in the September 4th issue of the journal Science, the brains of adults erect physical barriers that keep painful memories intact. As adults, events that emotionally disturb us tend to get seared into our brains, and those memories can resurface, causing anxiety, fear, and even post-traumatic stress disorder. But young brains are much more resilient, and can even erase unpleasant memories. To get a better handle on this youthful forgetting, scientists studied the brains of young and old rats. They found that in adult brains, a physical net forms around certain cells in the amygdala, a structure associated with emotional memories.
And we start today with a by-the-numbers look at a dangerous situation on Hawaii's Big Island. That's where the notoriously active Kilauea volcano has been erupting again for about a week and a half now. The first number we have is almost 2,000. It's how many residents have been evacuated since the volcano started this eruption. Dozens of homes have been destroyed by lava. Next, 12. That's the distance in miles away from the crater that ash plumes could cover if an explosive eruption occurs. Scientists expect more of those in the days ahead, and new lava flows are also possible. $2.9 million is the estimated cost in dollars that Hawaiian officials expect will be needed to protect residents affected by the eruption, and that's for the next 30 days. U.S. President Donald Trump declared a major disaster in Hawaii on Friday. What that
When you look at a lake, you are looking at a collection of molecules that have been there on average for about a decade. In the ocean, the residence time is thought to be more like 100 years. Altogether, about 60% of water molecules in a rainfall are returned to the atmosphere within a day or two. Once evaporated, they spend no more than a week or so, Drury says 12 days, in the sky before falling again as rain. Evaporation is a swift process, as you can easily gauge by the fate of a puddle on a summer's day. Even something as large as the Mediterranean would dry out in 1,000 years if it were not continually replenished.
As astronomers hunt for habitable Earth-like worlds, one popular place to look is around M-stars, a type of red dwarf. Couple reasons for that.
First of all, most of the stars in our galaxy are like this.
Eike Günther is an astronomer at the Thüringer State Observatory in Germany.
And secondly, the closest stars to us are like this. And thirdly, it's relatively easy to find planets around them which have a low mass or small diameter.
M-stars are smaller and fainter than our Sun, meaning the zone around them where liquid water could exist, the habitable zone, is really close in. And in that region around the star, it's also easier to spot small exoplanets with current techniques. A few months back, Günther had his telescope trained on an M-star 16 light-years away, known as AD Leonis, when he spotted a huge stellar flare. A Neptune-sized giant exoplanet lurking around the star appears to have survived unscathed. But the event inspired Günther and his team to ask how that huge flare would have affected a hypothetical Earth-sized exoplanet orbiting the same star. So they ran a computer simulation. The result? A shower of X-rays thousands of times stronger than what the Sun unleashes on the Earth would have blasted away much of the imaginary exoplanet's protective ozone. And multiple such flare events would be disastrous for life as we know it.
So this analogon from just taking the Earth and then saying, okay, we put it in the habitable zone, and that's how a habitable planet looks like, that's presumably wrong.
He presented the observations at the recent European Week of Astronomy and Space Science Conference in Liverpool. Günther says, if anything, this finding makes weird planets hugging M-stars even more intriguing in terms of planetary diversity.
I would say keep looking.
NASA's Transiting Exoplanet Survey Satellite, or TESS, is set to launch April 16th. If all goes well, it'll soon be looking too. On March 27, 1964, a huge earthquake struck the Prince William Sound off the coast of Alaska.
Out in the Gulf of Alaska, the ocean bottom plunges, then heaves upward a full 50 feet, and a wave starts racing for shore.
Powerful ever recorded at 9.2 on the Richter scale, and it killed more than 100 people. And just like the devastating Sumatra quake of 2004 or the Chilean quake in 2010, the Great Alaska Earthquake struck right around the time of the full moon. Coincidence? In 2016, Japanese researchers concluded that large earthquakes might indeed be more likely to occur during times of significant tidal stress. That's when it's either a new or full moon. And the news rumbled through the media, despite the study's small sample size of just a dozen large quakes. Now seismologist Susan Huff of the U.S. Geological Survey has done a much larger analysis. She plotted more than 200 big quakes, magnitude 8 or above, over the past 4 centuries, looking to see if they were any more likely to strike on certain days of the year, or during key phases of the moon. The answer, neatly summed up in the study's one-word abstract: no. The study's in the journal Seismological Research Letters. That's not to say we don't know of certain factors that actually do increase the risk of quakes. Huff says the ground injection of wastewater, oil and gas production, fracking, and damming up waterways can in some cases cause quakes. Just don't blame it on the moon.
I happen to love this science, and I think this position in which we have placed it is inexcusable. It's not good for science, and it's not good for society. And I don't think it has to be this way. And I don't mean that this class should be easier. It shouldn't. But your perception of these two words should not be defined by the experiences of pre-med students who frankly are going through a very anxious time of their lives. So I'm here today because I believe that a basic knowledge of organic chemistry is valuable, and I think that it can be made accessible to everybody. And I'd like to prove that to you today, if you'd let me. Would you let me try to prove that to you? Yeah.
Abandoned pueblos are scattered throughout the southwestern U.S., and at many, archaeologists have uncovered a curious artifact, the skeletons of scarlet macaws. The bird's bright red feathers are known to have been an important status symbol, a signifier of prestige, for people throughout the American tropics and the Southwest, both in the ancient world and today. But macaws are a tropical bird, whose range never extended north of today's U.S.-Mexico border. So how did the Pueblo people obtain the birds? To examine the bird's origin, scientists sequenced mitochondrial DNA found within macaw bones from two sites in New Mexico, Chaco Canyon and the Mimbres region. Turns out nearly 3/4 of the birds had identical mitochondrial genome sequences, meaning the ancient birds came from the same maternal line. That suggests they were all the products of a breeding operation, perhaps in modern-day northern Mexico, rather than a random collection of wild-caught birds.
Now, the Earth naturally removes CO2 from the air by seawater, soils, plants, and even rocks. And although engineers and scientists are doing the invaluable work to accelerate these natural processes, it simply won't be enough. The good news is we have more. Thanks to human ingenuity, we have the technology today to remove CO2 out of the air using a chemically manufactured approach. I like to think of this as a synthetic forest. And there are two basic approaches to growing or building such a forest. One is using CO2-grabbing chemicals dissolved in water. Another is using solid materials with CO2-grabbing chemicals. No matter which approach you choose, they basically look the same.
Last year, astronomers observed 2 neutron stars collide, a crash transmitted in gravitational waves to detectors here on Earth. Represented in sound, you can hear a small upward sweep in frequency in the data, if you listen closely. Several seconds later, the first waves of electromagnetic radiation arrived here on Earth, the first time a collision has been detected by both light and gravitational waves. And it's in studying the electromagnetic echoes of the collision that astrophysicists have gotten a far better glimpse of what really happened after those binary neutron stars merged 130 million light years away.
Oh, yeah, absolutely. So it gives us an understanding of basically all the nitty-gritties of what is going on after the merger takes place.
Kunal Muley, an astrophysicist at Caltech. First, he says, the stars collided, creating a massive black hole-like object, which started sucking up the cloud of neutron-rich cosmic debris left over from the crash. But its appetite was limited.
It cannot eat all of it, so some bit of it basically escapes.
Those escaping leftovers spewed outward into space as a powerful jet. But along the way, Muley says, the jet appears to have interacted with that cloud of neutron-rich material, blowing up a sort of cocoon within the debris floating around the collision. Until finally, the jet burst out and slammed into interstellar space, releasing yet more radiation we could detect here on Earth. Crows, she says, are what's known as partial migrants. Every year, some members of the population migrate between breeding grounds and their overwintering grounds, like parking lots. But others just stay put. So Townsend and her colleagues wanted to know if that urge to migrate was something individual crows can turn on and off. To find out, they captured 18 crows from overwintering spots in California and New York. They fitted the birds with little backpack satellite tags and tracked them for several years. Overall, 3/4 of the birds migrated, an average of 300 miles. And more importantly, if they migrated once, they did it every year, suggesting traveling is not a habit they switch on and off. The researchers also found that migrating crows returned faithfully to the same breeding grounds every year, but they were more flexible on where to overwinter, which could be a good thing.
For one thing, its ancestors changed the Earth in ways that made it possible for us to evolve. And hidden in its genetic code is a blueprint that may inspire ways to reduce our dependency on fossil fuel. But the most amazing thing is that there are 3 billion of these tiny cells on the planet, and we didn't know they existed until 35 years ago. So to tell you their story, I need to first take you way back, 4 billion years ago, when the Earth might have looked something like this. There was no life on the planet. There was no oxygen in the atmosphere. So what happened to change that planet into the one we enjoy today, teeming with life, teeming with plants and animals?